Alt R. Okay. Good evening once again. Quick class or sikong sigiza. So akoina jikto is rotational motion ni aduga this is the third class for rotational motion. And akoina jikpo da rotational motion gi magi physical quantities khara naina adum anam loi naina gre ko. So as akoina naina the wali si ke do we have the moment of inertia of some regular shape bodies mazigi akoina ke do axis theorem ani kaglay parallel axis theorem habanga perpendicular axis theorem habanga adu ani du sizinaraga akoina moment of inertia of regular shape bodies si kamai to puthokani habama odagidi radius of gyration ka adumaina odesam atopa ke do rotational mechanics the based of question equilibrium adu da haidi rotational equilibrium na kaino ko no ka dumba sum exam question macham su khara ka inaraga lore. So aduna handaki upcoming test haitare economy chapter chapter 6 or normal system of particles and rotational motion je. So sida sarna cover to gi khali ju si system of particles and rotational motion je loin ta ni then gravity gi earth satellite ki mamangi portion ge ju handak test ya kani ko aduna no Kepler's law acceleration due to gravity at a height h at a depth d adugum na chingba loin ya kani aduga earth satellite ki the height kam wang thamgani natragana earth satellite ki velocity kya hoini earth satellite ki kinetic energy potential energy kya hoini time period kya hoini ka aduga sida leib earth satellite atopa planet amada haibdi kaidoba magi time period kya hoini kind of whatever adu mamyam do adu sing do di next test lakani ko aduna handaki test di earth satellite yauroi only rotational motion and then gravity da ngasai acceleration due to gravity at a height h at a depth d then aduga some potential haitare ko gravitational potential. So gravitational potential is hollow sphere solid sphere ko solid body hollow body magi interior and exterior ko inside outside the my potential is kamaina very to we call the base of question. That's it ko de hena kam tananga later ko. So let's begin today's class. Akoina last class ki hepatop aming si kai photo gray have the ko. So koi si question hot ki bane bam ngarang class the ko 1991 ki question hai tare ka. Okay yeah kai dana token angular momentum gira. Yes. So akoi token angular momentum ki question ko hot gram mathang the equilibrium of a rigid body ka si question ji taw dene ka. Then we have moment of inertia. Then we have theorems of perpendicular and parallel axis. Not an issue. Then blah 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 blah. Yam lai question ni ka. Yam lai angular momentum in case of rotation about a fixed axis. Then rolling motion. Okay. So dum theory katanga ta ga di ngasi class dum lotion bayam. Ko ngasi de yam sang na di lor ge. So ngasi adu joina consistency maintain tawning e ko adu na ngasi si khara tawsi. So koi ngarang si bodi tawgre adu na mathang da ke do we have the equilibrium of a rigid body tawgde ko. So let's do it. And which of the following statements are correct? Center of mass of a body always coincides with the center of gravity in a high ko. No myam lo na mo kumo ji kedoba asigi option statement 1 ji chumra lan ra haro. Center of mass of a body always coincides with the center of gravity of the body. Si chumra lan ra. No
Lale.
Lale Anjali lale thamamba Prithviras.
Lale sir. Lale sir.
Okay fine. Atai di noi chat lai ba kangbu gai di. Chat ki kangbu gai. Sinthoi tabra. Adagi Kingston tabra. Nikhil tabra. Lale ka. Now kenu hairo kanada hang ziga. Lan bagi maram hairo kai du bai lali no. Lan bai maram ji khangbra sir already nan class explain to gre ko. Center of mass hai bisi d kai do we have matam na madi gravity na gravitational force depend to deba madi representative point ne ko of the distribution of mass, of the given distribution of mass, and then center of gravity habisidi madi gravitational field natragana gravitational force depend taweba aduna majina balancing point neba ko ado sometimes moini si same point lay pi and then but not necessarily always habidi adum manani habdi leite ba ko ana force kharakan manakan da adum shift tawne ba center of gravity se yan dai ko but center of mass shift tawroi center of mass haisidi adum kaino tawni center of mass sung haisigi magi nang body gi my configuration natragana magi mass distribution do nang change tawdrigai center of mass sung ko so statement 1 is incorrect. Which of the following statements are correct? Statement number 2, center of mass of a body is the point at which the total gravitational torque on the body is 0. See statement 2 is chumra lan baharo. Mayam kumnaro chumra lan bra or khangde. Yes, no, I don't know. Chumi lali khangde. Sajai naro. Tahudre kananong kumge tanong
Lale
matahudre.
sir.
Lale ka.
Lale sir.
Atay di Kingston, Anjali, Prithviras. Lale ka. Anjali, kaido ba lali no? Lale di khang kay no hangde ba ka. Thongamba kaido ba lali no?
Sir, see the center of mass की definition नती है.
Okay, very good. Center of mass definition ate. Prithviras, kaido ba lali no khangbra?
Sir.
Kay no?
Khangde.
Hangde ba ka. Anjali khangba, kaya to ba? Khanga ba? Anjali?
Try kaugre.
Kaugre, okay. Kaya kaya. Center of mass ay sir na tayo do. Magi given mass distribution or arrangement do adu dugi representative point neba. And it has nothing to do with the axis of rotation. It has nothing to do with torque. It has nothing to do with gravitational force. Center of mass ay bisidi force kamari sunglay lena deba. Yan tayo ko ay aduga moina sida haji kaino habda. It is the point at which the total gravitational torque on the body is 0 on have ko. Adu the total gravitational torque is 0 the center of gravity haragadi yae statement 2 se kai ino amatam the gravity is in a gravitational force gi gravitational field na gravitational force na mana chingak pamatam da always it is attractive in nature so mana chingak pamatam da balancing point to aduduna ngasai gi aduda torque 0 neba aduna axis adu masa matanda adu axis to magi center of gravity found neba ana kay yung masi na center of gravity of a body is the point at which blah 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 si haram bata di chumam dine but center of mass di mari sungne le na di ko ana statement 2 is also incorrect. Statement 3, a couple on a body produces both translational and rotational motion in a body. So couple la is kay no khangbra ma'am. Physics da rotational motion da couple la is kay no khangbra. Khangi khang de sa sa na ro.
Torque. Torque.
Torque couple ga di manate. Kingston ju torque hai torque couple ga manate. Mana basi mana ina low was up to some extent. Kari haro.
Couple na force kaino opposite ani do opposite na pina doba.
Okay. All right. So atopa di kana atopa try to noro couple ga to kasi kay kanay dipole oirak kadaba. Okay, oirakanda. All right. So tumakadore ko. Atopa di try to ro. Anjali couple lady kay no.
It's talk hay khang edu. Atu di khang.
Okay.
Talk ay
To kay do ba? Okay. Atopa kay di try to ro. Atopa kay Sintoy Prithviras. Haro. ID talk na couple ga ji kay kane. What is the difference between
Sir, magnitude mana duga direction di opposite oiba couple.
magnitude ti mana ba direction opposite oiba kay no ba? force lo tok lo
Sir, force waiting.
force oi ne ko okay fine so alright noi na hai si dum noi idea di lei ko the clarity kitang wale ai matang harake prithviraj ki definition du dai hana horake ko prithviraj ki definition ji da kai de soy hai matam da direct parallel sorry kai oigedaba anti parallel oigedaba force ne ba ko aduga anti parallel oiba force si kai no hai matam da axis tagi ma si aziki force ani anti parallel oiba force ani si axis tagi kai oigedaba equidistant oigedaba axis tagi equal distance laigedaba equidistant ko so two parallel sorry two kari parallel nataba parallel ki opposite kai no anti-parallel two anti-parallel forces which are equidistant from the axis ko constitutes a couple haigedra adwa hairsi hai couple ad kai gum noina force ki mahutta noina talk haige haragadi talk the same direction da lei ko kai gino hai matam da sir hapet chok ma haige yong ko sida kai sakra sida ko for example let's say couple ama generate ho gaya haragadi screw later hai ko something like we have a kedoba nut harage ko we have a nut and sigi nut che koina laithoka doine ba aduna sidagi spanner ama tawraga ko spanner di khangi ko spanner ama sapsalaga magi kedoba sigi nut che koina laithok ning khala jeba adudi si sida ina force am som side pire aduga sida tok am generate tawre ona si rotate tawrani ko sidi tok ne ba ada kai gu maina som sigi spanner ji sigi mahutta khara sangwa ma haidin moigi keno naga sijinabudo workshop ta ga sinnabudo khara sangwa tawraga maji siga da nangna haidi som side ta somdana sijina somda push tawba sina somda push tawba adu siji kai do wi am da couple am generator ko haidune ba ko couple am generator ko matam da di sidalei ba force ga equal in magnitude but opposite in direction auna two anti-parallel forces ko which are kedoba equal in magnitude ko and then magi kedoba axis of rotation dagi kedoba equidistant oigadaba same distance lap kadaba adu oirakanda we get a couple but talk t sisina maram orga produce to talk to r cross f natra r di sile f na sile r cross f t matakta sida su kai do we have the r na som le f na som le r cross f t kana matakta on the same sense of kedoba magi r cross f chap manabe matakta dum le ni talk se ko talk t equina anti-parallel or opposite hybrid de talk t same direction labor and a couple on a body produces both translational and rotational motion in a body lali a couple on a body produces only rotational motion ko translational motion di couple na produce to ngam de atopa kaidoba force id couple na to force ama ko la kanda la kanina statement 3 is also incorrect now mechanical advantage greater than 1 means the small effort can be used to lift a large load sidim chu meka so mechanical advantage greater than 1 hai ji kaino have nangi input ka output ka du kaidoba kaido output by input hai tare ko abi nangi ngasai gi for example let's say nang na yopi ama sakat panatra na pot yam lumba ma mechanical advantage greater than 1 hai ga di let's say sida le ren kala je ko ana nang na sida kaide sida thamme po se ko ana nang na sida masi sisi let's say this is 10 kg ne kala je ba nang na sida masam thamme ba sisi kaino this is only 5 kg katang ne ba 5 kg tham ba si po se 10 kg thangala kani ba ko see this is known as mechanical advantage hai tare I want to have the 50 have the 100 newton by 50 newton hai tare ko is equal to 2 ana sigi system the mechanical advantage 2 lay ko on output by input to kyan tai ko haisa aduna that's known as mechanical advantage and greater than 1 higher get the small efforts in erga large loads lift away at ko so option number 4 is the right one now sida yung pagta sa auna
Sir.
Haro.
Sir, kaino couple dom daga habiwa ay fajana laksan ba ngamdre.
Couple haragadi nang na pot amazi for example let's say nang na bottle gi makum ama hange ko bottle gi makum ama hange bottle makum hang nang na som sai ta pa asom ungi som sai pe ga som da push to dro makum ji da som pa ga som na push to dra Gyan da right nang si ji hang matam da ai khuchi amana sida pai si ji na som da push to si na som push mai to hang de ne ba natra si couple ma generate to axis of rotation si lei de ne ba mai ai de ko ana kai de ni matam da opposite force ne ba abdi force ani di magnitude mana da ba ya de anti parallel oina da ba ya de ba amana kaido we have the towards the board changi matam na amana outward board ki mapan tholakadam ne ba an anti parallel where ba oire couple oi ya ga the force ani di da ka like couple lai ji ke no couple lai di ani na tro in layman terms common akoi language the couple lai di ani ne ba and a force ani ji karam ka the couple oi ni ha matam da they have to be equal in magnitude, they have to be anti parallel or opposite in direction, and they have to be kaido ba equidistant from the axis. On axis of rotation dudagi equidistant oigadam ne ba equal distance laina gadam ne adu matam da couple generate taweba gyan dai ko auna couple da kaido talk ta yenga di sida talk am yaw ni sida talk am yaw talk ani yaw ka de ne net talk si chawrak ka ne ba couple gi di gyan dai ta de
tare sir
ai ko aduna khoina kaido ya the pot khara yamna laithok pa de wa pot tu saina hapchal laga saina sumain to ga lei bane ana for example gari thau da steering je si couple ne ba hoi nang na kan nam ka tang pair ga di khang dre ko natra ga di ani mak sumain pair ga thau ta ga di the couple ama generate to gyan dai ga ja
tare sir
yare ko so
thank you
that's couple aduna moi gi option sing ji am phowa valid oidre option number 4 budi chumme option number 2 3 ga lan me si gi ji ki lan bane ba ko noi maning de yang si gi ji ki lan bane yare ko Mathanga, question number 28 is a rod of weight W is supported by two parallel knives at knife edges A and B and is in equilibrium in a horizontal position. The knives are at a distance D from each other. The center of mass of the rod is at distance X from A. The normal reaction on point A is an question because she's tausi. Let's solve this question. A rod of weight W is supported by two parallel knives A and B. The knives are at a distance D from each other. CDM live question in a Pazavran Kalagayam, kind of Pazav. Anyway, fine. Knife edges ani layering colors have a let's say this is a knife edge and this is another knife edge. Can I go so angle layer colors anyway? There. A rod of weight W is supported by two parallel knife edges A and B, and N is in equilibrium in a horizontal position. The knives are at a distance D apart from each other. Knife and easy distance D apart from each other. The line A. The center of mass of the rod is at distance X from A. Let's say CC, this is the center of mass, and CG distance X neighbor. Let's say. Let's say this point is A, and let's say this point is B. The normal reaction on A is, and see A is like the normal reaction, look I know have never. Yeah, I do the A in a balance story weight to put for have never. Yeah, bra. Yeah, I do regadi kadoni have the Akoina Siki question C. Kamaina approach Tony Kamaina Putokani have matam the net. Magi my center of mass is the layer because center of mass tagi si in x lapatar gadi si the kaitara si the d minus x laptro yan tabruta the brose taika. Okay, fine. Now it is in equilibrium mazi rotational equilibrium the neighbor ko. Auna kedoni amatam da pot si kaigumba spin tawreba mai si axis da aduragadi ma sumain spin tawpata argadi r cross f or gadi r cross f auna amana somgi according to the point a ko talk se talk a som the tholakane this is tau a r cross b tawragadi r cross b ko so r cross b or asom chakiba duna talk b jina asom the chakiba this is tau b ne as this is an equilibrium the laibinina tau A should be equal to tau B. I mean, due to A or due to B or whatever you want to say. So aduragadi akoina obviously weight ka sigi perpendicular distance horizontal direction gadi 90 degree da laibanina akoina sin 90 degree di 1 ina akoina adu low da su yare ba ko aduna akoina just direct kai heavy have the x harga magi weight to is laibado adudu tasengna have the in a normal reaction in low yabudi ai ba ko but anyway road sigi weight w ni hai ko moina road sigi weight w si kai da laini ai matamda sigi mapa si da ko laigadoi aduna ai kitang diagram si kaino ne hapke ba ko si na taw yo helasi aduga weight w si da laitone weight w ka aduna adu oiba taragadi weight wc kaiga manani haiba matamda sumain tawroige ko adudi ai sumain holaroi habdi ai question sigi matung ina ni sir na holaise ko wz kaiga manani haiba matamda sidal mana maram or som da pitara ko force to kaino habda n the given normal reaction haita n ko n haraga into n tarni ko yes n tarni normal reaction da n leire khalaje ko adu du puthokadoi ko force aduna magi equilibrium ni nang zero level ko ado asom side na b da lei du sina kaino habda w minus n di level ko aduna let's say normal reaction the level taraga this is w leire na n is w minus b number reaction je khangdeba ko ina ko duna 1 second sumaina hana yengs do ibitaraga di x into n r cross n do ko x into n au dai plus amazina kaina habda d minus x into w minus n eba ko is equal to 0 ne d minus x haraga w minus n haita sumain tawna fabra natragana kaina fai somgisina n to amazin w minus n oin lawba aduti kanabra kanadabra yengi ko the road of weight w supported by the knives are at a distance d. The center of mass of the rod is at distance x from a. The normal reaction on a the level normal reaction put I am never ka adu the n put I am never the na c pot sikra budi chauthorani. So anyway let's see xn plus dw lere minus harga dn lere minus xw lere adu plus harga xn lere is equal to 0 minus plus ka xn ji sida di yaudabani. But anyway yengsi kamaina kai tarake yengsi ka makadam yengsi. So ani is equal and opposite sum to the 0 tagadam ka sum to 0 tagadam yes kai ngoli som thamagana minus we ka mani si chumi adu regadi aina kidawi have that 2 am ya sidai 2 am tiyawde ka fractaize n ga auna aina kidawi have the 2x minus d times n is equal to harga d minus x minus d harga w asomda pugi bagi ka adur di n je kai tarni have the ai si je kitang muthaga pukhat ke ka don't worry. So let's see how do I get n is equal to x minus d by 2x minus d times w ne ba so cd out rave option da ka duna kain am sure ekhoi gi si kai de so empty yeng ka xn jina talk se xn ka my numeration na hoi dum doin lor je xn ade amo jina kai na the w minus n ta ne asom the balance to the weights in w minus n ta ne and my distance na d minus x ta ni kem kai de aduga into to matam da d omega then minus dn minus x and then plus xn si leba ko aduna sigi pot si cancel out chat kiba ko ani sum to matam da ani sum to matam 0 chakadam kaino it is an equilibrium natra sign mistake labra ko 1 second kaigumba ina sigi pot si sumaina holam batar gati kamain tawa 1 second dw is not d omega minus dn minus xw plus xn the xn cancel sakraba na n is common log d plus x times n is equal to d times w n is equal to d by d plus x tabra si yaudeba ka d plus x makhada na dw by d plus x ka adudi yaudre sign ji kainam soireba ka in soiri ji kaidanam tang yengge d our distance d, but the center of mass of the rod is at distance x from the normal reaction on A is an abaco. Kai is very no. I will see W is equal to n laser in a komasagi. Do it with target D 1 second ka. Kai is very no. 1 second ka. Ecco qua. Kai is very so in the produced over kasi can kai the brand khalle ka kai is very no do it swinging I delete into it Serna holisita swinging I see delete kadai the swear no I do aina mit takpagumba am tayong ne mit takpagumba yawrang xn zika create na ko auna aina n pambane ko aduna dn je som pugre ko oh adu this is d minus x ne as ka sitos sida yung ne noi myam khangbra sida ken to ja sign mistake ama yaw jong sigi sida si step sila ko da myam sigi sign mistake se khangbra sigi se aina siga si ka krena dn je som chakre audi siga si le hode ne d minus x hoi dine bise gyan dabra ai kamai to sui gren ai gyan ta kamai to sui no gyan ta hodre si dn je som pure ko aduga siga le hore ba w je ona d minus x times of w ne ba adurga dn is equal to harga d minus x moi sigi je ta da male w by d option number B is it? Yone, tabrion. B tabrion option number.
Tai.
Tai ka. Soiro na tam madim soi bzani. So anyway, so mind to what could we never ka. Ona CG question Z dum. Again, yam live question is na plus minus to will show you agi kitang kano to gre ka matam ka chang to kra ta. ꯑꯩꯁꯨ ꯀꯩ ꯋꯥꯈꯟꯗꯅꯣ ꯈꯪꯗꯦ W ꯒ ꯀꯩꯅꯣꯒ N ꯒꯁꯦ ꯃꯤꯛꯁ ꯑꯞ ꯇꯧꯔꯦ ꯃꯥꯏꯅ ꯉꯥꯛꯇꯪꯒ ꯑꯗꯣ ꯁꯤꯁꯤꯗ ꯇꯧꯔꯤꯁꯤ ꯀꯩꯅꯣ ꯍꯥꯏꯕꯗ ꯁꯤꯁꯤ ꯒ꯭ꯌꯥꯟ ꯇꯥꯕ꯭ꯔꯕ ꯁꯤꯁꯦ XN
ꯁꯥꯔ ꯑꯩꯗꯤ ꯑꯗꯨꯗꯩꯗ ꯇꯥꯗꯦ ꯑꯍꯥꯟꯕ ꯏꯀ꯭ꯋꯦꯁꯟꯁꯦ
ꯑꯣꯀꯦ
ꯇꯥꯒꯦ
ꯁꯤꯒꯤꯁꯦ
ꯇꯧꯋꯦ
ꯒ꯭ꯌꯥꯟ ꯇꯥꯗꯦꯕꯀꯣ ꯁꯤꯒꯤ ꯐꯥꯔꯁ ꯏꯀ꯭ꯋꯦꯁꯟꯁꯦ ꯑꯣꯀꯦ ꯌꯦꯡꯉꯣꯕꯀꯣ ꯁꯤꯒꯤꯁꯤꯗ ꯍꯥꯏꯗꯤ ꯍꯧꯖꯤꯛ ꯌꯦꯡꯉꯣꯅꯦ ꯁꯤ ꯔꯣꯗꯁꯤ ꯂꯩꯔꯦꯕ ꯁꯤ ꯔꯣꯗꯁꯤ ꯂꯩꯔꯦ and then ꯔꯣꯗꯁꯤꯗ ꯍꯧꯖꯤꯛ ꯀꯩꯗꯧꯋꯤ ꯍꯥꯏꯕꯗ ꯍꯥꯏꯗꯤ ꯀꯩꯗꯧꯕ ꯁꯤꯒꯤ ꯅꯥꯏꯐꯁꯤꯒ or whatever ꯁꯤ ꯑꯅꯤꯁꯤꯗ ꯕꯦꯂꯦꯟꯁ ꯇꯧꯗꯣꯏꯅꯦ ꯃꯥꯒꯤ ꯋꯦꯠꯇꯨꯕꯨꯗꯤ W ꯂꯩꯖꯔꯦꯕ but sidayisida mana weight khara let's say sidayisida W1 hayage and sidayisida W2 hayage ba adi W1 plus W2 si W ga manaroidra abdi sida mana support to is weight 1 hadi suppose akoi ni pot ama paiminare kha nangna som paire aina som paire adudi akoi ni na pai du adugi force ani akoi ni da phangi force ani du plus to mai weight to natra akoi na puri se thangali je total do ana W1 G yam saying na have the downward ni the numeration upward ni and ani do equal and opposite oin ani equal in magnitude oin na ina W1 plus W2 equal to W have more than N1 plus N2 and is equal to arga minus W high gera or W high gera dum yare ba magnitude to the N1 plus N2 is equal to W high bi ba numeration upward ne kay no the N2 ga W2 ga manai N1 ga W1 ga manai ba gyan tai ko abra tai Tadabro circuit ang taija.
Tai sir.
Sir, tai.
sir.
Adu ragadi kedawe matamdane. Hajik pose equilibrium laibnina. Magi distance let's say si x1 lapeva, si x2 lapeva. Adu ragadi mana generate to maji talk ama generate tawningewa. Si centrum mass si id laire maiko. Or again, si centrum mass dum center of gravity su laitene kay gravity is uniform wave. Ano maji rotation thokning maneva. Rotation thokning mo matamni si na phari neva. Si ju som da rotate tawning sin phai neva. An somgi dudi talk dudi kay na r cross f neva. R kayuma sigi knife se layam da gadi maso dem ki rotate to kaneva natra kayuma sigi knife layam da so dem ki rotate to kaneva knife ani jina phai neva knife agera support agera whatever hanging bayo ani jina phai neva ana magi distance kaino x1 lape force ina kaino n1 ni adu som da leiba tok se sida leiba tok se kaino sida leiba tok ta 1 ji kaina da let's say x1 vector cross n1 neva n sida leiba tok sina kaino habda tau 2 jina x2 vector cross n2 neva natro ado sigi support lem de sigi ungdara kane rotate to kane si weight na push to kane gyan da right r cross f si r ni ko x2 ze r neva so I to x1 na r neva r cross f neva awna kay dawni have ani mag rotate to dragadi to ani ji kaino to ani ji equal oi have neva to ani ji equal oi de how natro xn is equal to x2 to d minus x and n2 to the w minus n natro how they equate to ko ta in gyan tar bai ja ta dre ngorbo
Tare sir.
sin ta ine sinthoi tabra odagi prithviraj thongamba tarba
Sir.
Sir, tai.
tai ko adi wani to ko sumai to hot pe wani okay fine yare so let's move on to the next question akoina kai lere je question number 29 jidi vector in no idum ngambre one ABC is an equilateral triangle with O as its center. F1, F2, and F3 represents three forces acting along the sides AB, BC, and AC respectively. If the total torque about O is 0, then the magnitude of F3 is an hypercore. So, asidi ilai no yone question show hota bidang ngambre.
Sir, B oidora.
Okay, B is equal F1 minus F2 na. Okay, since we A hai F1 plus F2. Yung ko, pot si kaido we have the C sina F1 som challe ko. So magi kaido ni have the again C equilateral triangle ni na sigi F1 ga F2 ga ze ko same sense of direction the later ko. Auna kaido ni matam da if the total torque about O is 0 never. So aduna now torque si ahum delay never due to F1, due to F2, and due to F3 never. Due to F1 is kind of the R cross F1, due to F2 is kind of R cross F2. Now, kada we have matamda R cross F1 plus R cross F2 should be equal to R cross F3 never. Gyan tay tate tay ko. Sigi question si gyan ta bro. Taram daw man din noi. Kumakti duga taram daw zuma laktre. Ay talk. R di lunchap man kay this is the centroid and then they are all equidistant. Distance lunchap man si na kara wang ba mandra. Equilateral triangle hai ba ko O is at its center am ni na. Kay no taw ni ba ko loy na mag lap loy man ni ay ta. Equilateral na si dai ju si dai. Adum loy lap man am say. On R1, R2, R3 hierarchy ba ko R cross F1 plus R cross F2 should be equal to R cross F3 ne. Ado si di loy 90 degree ne R ga F plus 90 ne ba ko my direction on RF1 plus RF2 is equal to RF3. RR kakta kredi kay tare F1 plus F2 is equal to F3. Now option number A is the right answer. Gyan ta dabra?
Tare.
Tare ko. Ta diye. Kingshan ta hudra ba? Kingshan gising nasay ko magpaneba ko hasiki pa din natin. Atay di loy gyan tarba, Sintoy tarba, adagi Kingshan, Nikhil tarba. No response. Kanam ko magtre.
Sir tare.
Tare, thong tare. Okay. Matang yengasi adudi ka. Kaidawa Sintoy tare na ka. Matang is the center of gravity of a body is the point at which the weight of the body acts. Chumra. Question number 30 is yung.
Chumme.
Chumme ka. Okay. Aduga question sige my option number 2 is the center of mass coincides with the center of gravity if the earth is assumed to have infinitely large radius. Now, whether the earth has infinitely large radius or not, center of mass is assumed to coincide with the center of gravity ka. Dagi option number 2 is lali. To evaluate the gravitational field intensity due to any body at an external point, the entire mass of the body can be considered to be concentrated at its center of gravity. My gravitational field intensity the entire mass to my center of gravity, the lay ana koina consider to at any point. Then the entire mass of the body can be considered to be concentrated. No, entire mass in never center of gravity the lay in a can be arroy. Entire mass to the center of mass lay in a dum kangani ka. Whether we want to find the gravitational field intensity or not, center of gravity the kind of mass to the lay in a can the radius of gyration of any body rotating about an axis is the length of the perpendicular drawn from the center of gravity of the body to the axis and a so this should be drawn from the center of mass to the axis center. Option number 2, 3, 4 option number 1 is the only right answer. Again, center of gravity of a body is the point at which the weight of the body acts. Yes, sibudi chumme. Option number 1 chumme buko. Option number 2 lale, 3 lale, 4 lale. Sisima achumba ambo yaudre hatai. Gyan tabra tatabra. Taiko. So CZ controversial question even season. Duga radius of gyration ka center of gravity na the center of mass ni buko. Axis to center of mass oigadam ne. Yeah de. Yeah bro. Ma'am.
Sir, point number 3 dum ta habiyo.
Point number 3 zero. 2 kaidova evaluate the gravitational field intensity due to any body at an external point. The entire mass of the body can be considered to be concentrated at its center of gravity in high level. Akoina kaidowi hamatam da gravitational field intensity sarnana yekibudo. Center of gravity to shift oina field kan mapa to shift away. Gyan dai ko. Field kan mapa to shift away and adugi point to the akoina balancing point to lay haiza by one eboko. The entire mass of the body can be considered to be concentrated at its center of gravity hargadi adudi la leva. Mass sabdi ngasagi kaidoba center of gravity is the center of mass ka manadeva madi gyandai ko aja madi akoina entire mass aduda lay kainaga khanbasu yade madi representative point nateba madi balancing point neba ko auna kaidowi ha matamda akoina gravitational field kaidoba strength se intensity se gravitational field intensity aigera gravitational field dang aigera adu puthokpa matamda when center of gravity si changbudi changi ko habdi center of gravity du pala hola kadem but entire mass of center of gravity layena khanbadi yade ko adu gi wane entire mass is always center of mass layena consider to budi yai center of gravity de layena consider to budi shuya yade gyan tai ta de tai ko madi kenu ne ba habdi ngasagi akoina habdi entire mass kan si du de layena consider to ya du si di kai de yani ha mudam center of mass de yani center of gravity de yaro yare ko aduga adune adumain lay ko aduna concept si mana deva center of gravity ke center of mass ke concept mana deva ko adugin. So option number 1 is definitely right. Option number 2 with 3 ke 4 ga lale na moi ki ji keno di to arni ko ki ji lan mani si question je ko ki de kai hoi si gi ja am te yone to don te ni questions pung ji mapan ta ge ngau de
oi.
the option number 4 is to marry mana 4 is definitely lale because the radius of gyration of any body rotating about an axis is the length of the perpendicular drawn from the center of gravity to the center of gravity of the body to the axis. Si lale ko this is the radius of gyration na te ko adu one. And sir no the moment of inertia ga radius of gyration na punna talakani ko ado kano ni hazizik pudi kano tawdri aduga moigi definition si the dear definition of radius of gyration sigi si lale ko incorrect ko. Now question number 31. A rod of length 3 meter and its mass per unit length is directly proportional to distance x from one of its end, then its center of gravity from that end will be in Habakkuk. So kisi question number 31 is fazai 32. So question number 31 is tawsi ko question fazai masai dan should be the plus minus the special luck with the factorize ko. A rod of length 3 meter and its mass per unit length is directly proportional to distance x. Adu is sumain layering kalazibu ko rod say rod of length 3 meter total length is 3 meter never ko and magi kada we have the aina yam pick but dx am lower gets the ko. So and its mass per unit length is directly proportional to distance x from one of its and then its center of gravity from that end will be okay again center of gravity ka is a center of mass and center of mass ang gadam ne ko. All right, fine. From which end? Hagadi from this end. Ka. Aduga magi center of gravity haiba matamda kaina kaidoni ha matamda ko. Moin actually hangning is center of gravity na te center of mass ni. Center of gravity di again earth ki mapada budi chappu di mana ko earth ki surface the center of gravity ka center of mass ka chap mane. Anyway, kamai to puthokane the is proportional to distance x from one of its end. So from this end, from A haitare and B. Center of gravity or center of mass putokwaji always with respect to some position ne some day putokadini bako. Auna aina ke do we have the sida mass macham lorge and my mass ikain lorge my mass dm never. Adudi we know that xcm is equal to summation to cd integration on learning dm haraga magi kenosina kaino the magi arapaze from the axis ka my distance to the kaino my distance to the it is I think okay my distance to the sidensi bola paze let's say this is small x la pen kala je ko auna dm into x ka dm into x height ko x yes dm into x later ko okay fine and then uniform mass per unit length harbanina dm by dx should be equal to total mass c piramde total mass m nen log m by 3 aduna ina kaido we have the dm is equal to m by 3 dx and low vi aduna x haraga dm gi mota m by 3 dx and low vi aduna 1 aduna m by 3 common lower kanda x se kaido we have the x square by 2 lani adu integrate to matam da kai den kai pung have the 0 then 3 both torni aduna 0 then 3 both to matam da mz kaino mz amuk fraktai ka wait okay by total mass m amna yelam drise one noi ju hairakte sarju uhodre noi gyan tabra sir na haija ha
Tai sir.
Aisa.
Tai sir.
aduni kano na aidu kano to hodre me total mass m na yen gadam na tro sijibo central mass ne me si m na yen gadam ne I see 1 by m adudi kedo ba si 1 by 3 dang ta ni ko m by m ka kre aduna 1 by 3 the 3 squared is 9 by 3 into 2 ka minus 0 do ya 3 3 is 9 the 1.5 meter tabriyo tabra ying drobo no amti ying hayo na
2 meter tai.
kay ba jigida
B tai và option.
option b ta ya option b ta ya ko 2 meter adu di kai na sure from which end from that end have never got from that and xcm input is kaina input is central mass ki and its mass per unit mass is directly its mass per unit length is directly proportional to distance x have never got so this mass my god it's sir gizi kenam soibam le question ni muna powder its mass per unit length is constant have na table ko aina sisi mass per unit length is constant ki wakan na khaleje auna dm by dx total mass m by total length 3 is sumain low mutam tarani jine question is square measure and whole is ko abidi concept se kitang misinterpret to bam yaure aduna amtang hot ke ko si dum lai kem kaide si dai du soiba question ji mun powder moi ke si 1.5 se lai je onana question hanjan practice to wide sir asi kem kaide ba dm by dx not dm by mass per unit length am na dm low ko dm by dx si kem kai de ko and then mass to m do total mass lor gadi total length to 3 tar ne si ju kem kai de which is again so aniji makte amadi low da dia roi ko auna adu du ke do ba directly proportional hamina is equal to k times of x ne kai no the moi the kai its mass per unit length is directly proportional to distance x have gyan dai ta de aduna my mass in dm my length in dx to adu directly proportional to kx neba adu idi kai do ya dm is equal to kx dx and haiba natragana m is equal to kaino 3k x dx and haiba gyan taita this is taiko sida neba sarna kena to kitang shora message da uhodre uhodre de na mass per unit length constant and losalre audi c gi c kem kai de akoina hana ngasai torom misdi kem kai de ko ana sida dum hotar regime makata na ko dm gi moto kai torne ude integration of k x k le ko and x le ko and then dx le ko then x amo sigi di x square le aduga and what is m gi moto kai le any of the 3 kx and dx le ko sorry m gi moto 3 kx happening not dx your gyan tabra si se taiko adu ibataragadi kaido we have the mathaki sida aina sida 0 to 3 lerni auna aina k zi putho cancel chakre do k lere x square sida toragadi x cube by 3 haraga c 0 to 3 oidini aduga amazina 3 kx oidini k ga cancel chakre aduga c gi x c aina kaido wa c 3 kx oiba distance total mass se sumain to bona phabra natragana sumain oin to siko m by 3 kxc aina 3 direct mention bodi ai do adu phajade adu shokpudi aina integration dm direct torage ba ko makhagi se aduna hena pharani id total mass m have integration dm ne ko integration dm auna integration dm oin to bona hena pharani si matang sida ko so integration dm toragadi kai tare integration of kx dx tare and then integration of kx dx kai tani integration of kx dx k x square by 2 k x square by 2 are 0 to 3 tani and k second to chakre auna sidi kai tare have the 3 square 9 by 3 divided by 9 by 2 adu yogadi 9 cancel chatlaga 2 tare concert sa sumain to 2 taga da so no isi keno ta hobra gyan ta hobra sir sigi je haporogi gyan ta hobro si se kanam ko moktre ta ha ta dro
Sir
ma
adum tai.
ta
Tayo
ya
sir.
Sir adum tai.
adum ta ba ko so sir na ngasai aham soi ji kai de soi no have da question ja its mass per unit length is directly proportional to x have an ever adu the dm by dx is proportional to x haga proportionality constant k to si have kadam never aina kai khalu yonga its mass per unit length is constant have wakhan da ne sai khali do yan da right ja auna aina khanbado adu da dum mai di adumain toraga solve torokani sir di ko adu di one anyway yare durga di next question the proceed to ziko ko 250 Newton forces required to raise 75 kg mass from a pulley. If rope is pulled 12 meter, then the load is lifted to 3 meter. The efficiency of pulley system will be in a so sis dekhanga dra yo question pare yo yo I see 250 Newton force is required to raise 75 kg mass from a pulley. If rope is pulled 12 meter, then the load is lifted. Have a connoissance kanam ko magting amni ko nil sir duodan sir antorag. $250 Newton force required to raise 75 kg mass from a pulley. So load chi kaino load cha load si 750 Newton. Effort sina kaino? Effort sina 250 Newton. If rope is pulled 12 meter, then the load is lifted to 3 meter. Okay, 750 Newton. Aduragadi akoina output say input sina kaino? Input energy is equal to effort into side distance. And effort is 250 Newton into cap 12. Adu output sina kaino? Output sina load into 3 meter. Adum again, this is load ki distance. Haita si D1 harage, si D2 harage. Dun load si kya no? 750 natra. 750 Newton into 3. Adu the efficiency harage di output energy by input energy. Haita reka. Adu putho kay tay. Kaktan naro kay tayo. Output adu the efficiency kay tare.
75%.
75 tabra. Efficiency is equal to output by input haita. Output by input ka. So output energy by input energy haita, which is equal to output is 750 into 3, 250 into 3. 250 into 3 di kaino 750 natra. 250 into 12 ne sumai ne sura kadi to isa je wara amni ko sharan turan ure mitse. The 3 4 12. The 3 by 4g kai tai 3 by 4g nang na percent don thoke is equal to 75%. 1 by 4 na 25%. The 3 times of 1 by 4 is 75%. Answer 75% tablo.
Tai.
Tai ko yai ko. Okay, so let's move on. Question number 33. A couple produces A couple produces what? Purely
Purely
rotational motion.
rotational.
Very
Easier.
good. Very good, very nice. Question, okay, moment of inertia. Moment of inertia is the moment of inertia gi regular shape bodies ki moment of inertia khara ko talk to the oh, thank you, Rosen. Thank you. So domain lere duna sisima next class tausi already 924 body chat le aduga theorems of okay theorem mani khak take ko tu na hita yam tun take matam yam lo de easy ko. All right, parallel axis theorem ga perpendicular axis theorem ga take ko moment of inertia adi kamai da putokani na ko. So let's say this is the graph me to again. Sorry. Kay han tausiga perpendicular han tausira. Perpendicular axis theorem.
Incoming voice call from Vijayendra on Sachiu.
Duga amaga tauge ka amazina parallel axis theorem ang tausika. So ani tawri yengsi line packet crava to is share ka. So aham bagi line yu pay have kang no item line pay bizika. All right, so noi yamun tau ko sisi sar yam ten na yam sam na hai gebo ko ani ji kai kene. Now perpendicular axis theorem zidina only for two-dimensional bodies never. It is applicable only to two-dimensional bodies. Parallel axis theorem zidi generally three-dimensional bodies to in a pali ko adu yeng seva kamay no. Now perpendicular axis theorem na is kind of any plane any plane circle disc kite whatever anything any plane magi moment of inertia about this axis ka sigi direction sida, and then adudi mangonda mutually perpendicular over axis si kedoba adum 3 lines lay tuneba ka ana magi sigi axis sida layba, and then sigi axis sida layba sigi moment of inertia ahumze. Let's say this is ix, and let's say this is iy, and let's say this is iz. Adudi iz say the perpendicular axis the labor moment of inertia da my plane the labor moment of inertia ani do samduga mananiaba, provided the three axes should be mutually perpendicular to each other. Moisi all three of them should be mutually perpendicular to each other. Gyan taita de tabro
Taisha.
taiko dana CG dong perpendicular ID moi loinamak si mutually perpendicular oina gadamne gyan dai ko ja duna kaidoni habda again CG point si kai de lay duno lining ba lay suno my centro mass da kata de it doesn't have anything to do with centro mass CG si nang na FD habdi kaina bisana na si pocha swai de shift or swai de lehlo ja swai lehlo ja anywhere lining ba mapam de lay ba ko kaidoro kani hamatam da adum CG is always true in here, and it is strictly for two-dimensional bodies. Strictly for three-dimensional bodies, the perpendicular axis theorem paanya deva. Now, some regular shape bodies, the perpendicular axis theorem come pan have the ring pan bi, disc pan bi, then any rectangle pan bi, or any square, anything which is a two-dimensional figure, lonya. Now, parallel axis theorem di parallel axis theorem di any magi kedoba any sphere natrana any solid amlere. So magi center of mass amle any my center of mass power moment of inertia amle ni. And adu duga parallel oiba mapam ame heta da laser no mapam ame heta da. And axis and easy parallel oida di ade, and axis and easy mark the labor distance let's say d ne kala de. Adu oiba targadi si sina center of sina center of mass the fauba kedoba axis to neighbor ka adugi my moment of inertia am le sina I neighbor adu the I have is kaino I matam the ICM plus entire mass of the body into distance square. So this is the formula for parallel axis theorem have neighbor ka auna parallel axis theorem jidana le is kaino I matam da the moment of inertia about any axis which does not pass again even if it passes through the center of mass ka adugo yani ka distance 0 am sitam jawra ro ko on center of mass ka mane harane ana ke doni have the any axis any random axis any solid amagi any random axis ta in rotate to matam the magi moment of inertia si kya ta gani habsi according to the parallel axis theorem adugi axis to ga parallel oiba center of mass ti power axis amada leiba my moment of inertia do adududa kai plus to sundeba the entire mass of the body into the distance between the two axes md square plus to sundeba aduga phangkani ba I do ka koi gi I do I ne ba koi na pami ji so si I ji si ga chamane ba ko so me am le ma gyan ta obra so jaina ro
Tahoe, sir.
Sir,
Tahoe, sir.
tahoe.
prithviraj ta bra
Taisha.
okay Kingston Nikhil Sinthoi thong ma bu ta hai ro male ko si ani theorem is yam powerful oi ba ko aduga theorem is kai do yam powerful oi no ha matam da moisi khanga ga din na regular shape bodies ki magi moment of inertia je am nine bu to pangam ne ba yan da bra for example habdi this ki mai da pau do khanga ga di mai tangent laiba natra mai marak ta laiba kaina and then noina Nikhil na sir da hang ba question do sir cavity ki problem na any solid am da mai cavity da laiba magi asuk si aina lokthok ki bata ga di mass se asuk r/2 gi spare ama radius r/2 spare am lokthok ki bata ga di remaining du gi my center of remaining to moment of inertia about this axis kai oidinu kai ji no si khang da na suya ya roi ko si khang di am line ni ko ana si ani ji phajana khangom da ka oi so si ani ji phajana khangjulo aduga ngasi di am sang nu tawdre sir ju am tina chokthare ko ana ngasi ji class si ai recording ji so I stop torge so thank you for the class And let me stop the recording here.